Hi and welcome. It's time for Physical Sciences and you are watching Matrix Uploaded. My name is Tinyiko Kosa and special welcome to those grade 12s. I know this is your program. You have to watch this. It helps you with your lessons in Physical Sciences. Now, today, what are we going to talk about? The lesson is on projectile motion. What is projectile motion? This is the kind of motion that objects undergo when you throw them up into the air. Okay, for example, here I've got a golf ball with me. If I throw it up, look at how it is moving. So that is a projectile motion. And we're looking at the up and down of it. So we're looking at it basically in one dimension. The projectile in this case is the golf ball. It is the projectile. And the process is a projectile motion. Okay, now let's try and describe what we saw. As the ball moved upwards, we realized that it is decreasing its velocity. In other words, we project it upwards at a certain velocity. But as it moves up, that velocity decreases. But we also know that when the velocity decreases or changes in any way, okay, there must be a force acting on the object. Therefore, the object is undergoing some acceleration. And the fact that this ball is decreasing its velocity as it moves upwards, that would tell us that there is an acceleration acting in the opposite direction of this motion. And of course, that will be acceleration due to gravity. We'll talk more about that as we move on. Another thing that we're noticing is that as this ball goes upwards, okay, it gets to a point where it stops for a while, just for a short moment, and it begins to come down. So that also tells us that we project the ball at a certain velocity, which we could call our initial velocity. But at the point where it turns and comes back, it stops for a while. That tells us that at that point, the velocity of the ball is zero. So the final velocity on the journey of the ball from down here up to where it stopped is it's such that the final velocity is zero in that way. Now, what happens afterwards? We also notice that as the ball begins to fall back to where it was thrown from, it increases its velocity from 0 to some value. And I can tell you now, the final velocity of the ball at the point of projection is exactly equal to the velocity of the ball when it was projected. Another thing I can also tell you at this point is that the time the ball takes to move up to the highest or the maximum height it can reach, and the time it takes from the highest or the maximum point reached back to where it was thrown from, those two times are equal. If it takes 2 seconds to go up, it will take another 2 seconds to come down. Now, the total time will therefore be 4 seconds in that example that I've given. So, in other words, if you want to know, if you know the total time it took to go up and back, you can just divide that by 2 or half it in a way, and then you get the time it took to get up to its maximum height. We can illustrate that graphically quickly if we have a look at this. Projectile in one dimension. If we've got a ball like that, and we choose, now here, it's something very important for us to know. Let's choose to be, the upward direction to be positive. Because we're talking vectors here, velocity, acceleration, these are vector quantities. We have to show the direction. So if we take upwards to be positive, then let's see what happens when we throw this ball upward. That's the way it is moving. It reaches the maximum point there. Its velocity at that point is 0. Then it starts to come down back to where it has been thrown from, okay, in that direction. So the velocity is now in the opposite direction in that way. Okay, so that's what we have. Now, in short, that will be the way or the path the ball took, okay, back there. So up is taken to be positive. If we take up to be positive, by implication, down will be negative. So because we said acceleration is acting opposite to the upward direction, it means that we will be saying that this acceleration will be negative because it's against the upward motion. Okay, in that way. Right, hope you enjoyed that. Let's see you in the next section of the lesson.